Hi everyone. I hope you can hear me well. My name is Alex Unger. I'm originally from Cuba, but I've been living in Germany for a long time now. And I wanted to talk to you about a new project that we are undertaking on ownCloud, which is called Infinite Scale. So you can find me on GitHub address, and yeah, a little bit about me, more, and also a little bit of introduction to ownCloud. I've been working with the company for 2 years now. They basically have been hired to rewrite the entire application that they had from PHP to Go. So using Golang and new, more modern approaches to software development. In a nutshell, what ownCloud does is we are file sync and share company. So we basically, you can imagine Google Drive, sort of, or Dropbox, but open source. So everything we do is open. And yeah, we used to have a really big community behind it, also driving the development, which is very helpful. So I wanted to talk about a little bit the requirements of the new project and the technical baggage that we had from the past. So there was the requirement that the product needs to be 100% feature parity with ownCloud 10, and then we could start adding more features on top of it. So ownCloud 10 will be the latest release from the old backend. As I mentioned, use new technologies like Golang, protobuf, just because we needed to set the contracts in stone, so we didn't want the contract to change between versions of the API. And if they change, protobuf gives you versioning by default. We also wanted to follow these microservices approaches. So we used to have a monolith, which was the entire ownCloud 10 server. It was basically a big monolith. So they went ahead and wanted to break the monolith in small microservices. So we have clear separation of concern. We can actually, the development is slightly faster. It's easier to also break down teams, and also ownership on different areas of the code is more, it's a clear boundary. So, and as far as I know, the approach that we follow for microservices is pretty unique, which is not a good thing or a bad thing. So we essentially, what we ship is a single binary, and within the single binary, there is a set of microservices that we start up in your local machine. And I've tried to look for instance of services doing this, and so far I wasn't able to find any. As I mentioned, there is a single binary. So one of the requirements was that it should be kind of plug and play. So you download your binary, you start the server, and you have an entire suite of microservices that do all the transactions in the background for you. And then the bigger change that we followed was that we are collaborating with CERN in what is called CS3 APIs. The CS3 APIs is essentially higher level protocol interoperability protocol that would allow different clouds to easily aggregate to imagine it like a storage mesh. So you would have main Riva is how we call the reference implementation. You would have single source where it's essentially routing to all the storages. So essentially a user can mount any file anywhere she wants, and you essentially are able to see the files from a Dropbox, Drive, Google Drive, any other implementers of the CS3 APIs within your client. That is the too long, didn't read. Usually, we encounter many challenges while developing, especially with requirements as tight as we had. They might not read really tight, but they were pretty tight for breaking such a big monolith. And the first one that we encountered was first of all, selecting a framework for microservices, which we decided to go for Go Micro, because we had essentially a choice of Go Micro and Go Kit, which are pretty well known on the Golang community. Go Kit was more verbose, so it would require us to do more templating and a larger code footprint for bootstrapping the servers, and a lot of interface implementations which we didn't really consider it was a good fit for us. So we decided to go for Go Micro, which gives us all the interfaces, and you just have to implement them. So that proved easier. There was also a really nice interaction with the Go Micro maintainer, Asim. So there was a lot of back and forth, and we contributed to the project, and he contributed back to us in the form of helping us with the infrastructure slightly. So yeah, the main challenge that we found with Go Micro is that everything is a CLI app, and wrapping a CLI app with a framework called your fave CLI proved too tricky. So we needed to start duplicating flags and propagating things that you should not propagate. And then the second challenge was the configuration. So we aim to be pretty flexible when it comes to configuring the application. So we allow config files, CLI flags, and environment variables. And it's not easy to nail this down pretty well. In fact, we are in the process of updating this right away to remove the CLI flags to prevent from dependency injection that just shouldn't be there. And also to provide same defaults. So, which means that when we ship the binary, we provide an application that it works on your local machine regarding of your environment, which is something that we can do pretty well with Go with build targets. And there was, of course, custom runtime. So if you want to do all this, you need to provide a way to orchestrate all your services. If you don't use a runtime like Kubernetes or Docker Compose, then we expect when you deploy the binary on any server that first you choose the right architecture, obviously, and then that you don't need to have any weird dependencies like Docker Compose or like a Minikube cluster running locally or anything. So what we did was build custom runtime, which is based on supervision trees. A supervision tree is just that structure that allows you to start, in this case, Go routines, emulating OS processes, and keep track of them. So you can actually control the entire lifecycle of a Go routine on a higher level with the supervision tree, which you can imagine just as a map from the name of service to a running Go routine. That is a concept that we did actually borrow from Erlang, and that running in this way actually allows us to do nifty things like having a really low memory footprint on devices like Raspberry Pi. So even though the application is pretty heavy on the back, when it comes to running it, it's very light. So I think the current memory footprint is 80 megabytes when it's running, and a single process. And then we have something that I want to mention on a deeper lens, which is a test suite. So the only reason why we felt comfortable migrating the entire ownCloud 10 backend into a new one is because we do have a test suite written in PHP using Behat, so it's behavior-driven development. And we can actually use the test that we have for ownCloud 10 backend against OSIS. And we came up, or Jankari Tech came up with the idea of some sort of, you can imagine as red-green testing. So we have the old test suite. We have a set of scripts built on top of it that would keep track of all the tests that fail for the new backend. And then developers would only work on the tests that are failing. We base everything on a markdown file. So when you fix a test, you would go to the markdown file, you would remove the line, and then CI would complain. And so you need to fix it upstream as well. So this is a peculiar case where fixing something that is working would actually cause CI to break, which is a funny concept at the beginning, but then it has proven very solid to work with it. And this way we are basically going for the requirement number 1 for feature parity. So we can move confident and safely that everything is working just fine. And there is yet another point here that I forgot to add, which is the performance. Obviously, that's why you undertake a huge project such as this. Just because we use Golang out of the box, we gain a boost on performance compared to PHP. And that was one of the main reasons why we went for Go. Obviously, we have concurrency. Obviously, Go is not a dynamic language, scripting language. So you actually need to reload your server whenever some configuration changes. So editing a file doesn't really fly with Go. You need to propagate changes all the way down to the system. So that's something that we are currently working as well. But yeah, performance is critical. So we built a set of benchmarks around all our ownCloud 10 versions and OSIS. So when we ship a new version of OSIS, we make sure that we don't make the whole system slow, obviously. Those were part of the challenges that we had. As I mentioned earlier, we are working on the CS3 APIs alongside CERN. And in particular, the reference implementation, which is it's living on the CS3.org/Riba repository. So you can have a look at it if you want. And as of today, CERN is already using the new system in production. So they are migrating all the users to the new, the project is called OSIS, ownCloud Infinity Scale, so abbreviation is OSIS. And yeah, we are essentially, this is where we collaborate the most. So CERN and ownCloud, we do have meetings every other week to discuss what are we going to do, because we share a roadmap. And essentially, yeah, that's where we actually collaborate. When we finish, so the workflow would be, we push stuff to Riba, then in OSIS would be like a wrapper. The main repository lives in ownCloud OSIS. We import Riba, and then we build the services on top of it. So it might seem a little hard to follow with so many microservices, but once you get into it, the separation of concern is pretty clear, and it's a little easier to follow. One thing to mention is that OSIS is not yet on general availability. So we still have some work to do, and I wanted to share our current roadmap until GA, which would be somewhere in between April or May 2022, so next year. So October, November was essentially focused on Office integrations, which are integrating with LibreOffice, for example, so you can actually upload your documents and edit them on any client. User and group management, which has proven tricky because we need to support LDAP servers, we need to have our own service accounts implementation, and then sharing and spaces. Spaces is a new concept that we are starting to work on OSIS, and sharing is the all sharing concept, essentially. Then on Q4 and beginning of Q1, we want to focus on more technical tickets, like build an event system that should allow us to do notifications easier, because notifications at the moment, the current implementation is a little, it's basically polling. So every 10, 15 seconds, you poll the server for changes on the server. and the license manager, a proper license manager, which we already have a concept for. There is a huge web design and UX rework for the web frontend. We do have on our team, we basically have 3 clients. We have a web client, we have an OS client, Mac OS client, and an Android client, well, an iOS client. So we actually have 4. So yeah, they all are in the process of migrating to the new Spaces API, which is higher level web dev endpoints, essentially. All this was essentially based on, so what drives us on our day-to-day would be to have an easy to adhere storage mesh. So as I mentioned earlier, you can imagine Riva as the guardian of the storage door, sort of router. So if you want to add some storage to let's say service mesh, let's say you're at a university, you want to share your files with other universities, or you're a user, you want to share files with group of users. If that's the way you want to do your workflow, then you would essentially use the Riva and the C3 APIs for that, which essentially translates into getting the binary, running it, configuring it, and then adding automatically your storage to the service mesh. And then you can start giving access to people. It's not that people can see everything right when you join. We also want to focus only on file sync and share, except for on top of the Office integrations, of course. So collaboration will be still there, but the focus will be on file sync and share. So sharing with other people is also is fast, is easy to find users, is not really rocket science. We aim to have an approachable code base, which is something pretty desirable but hard to do, as some other people working in open source code probably would know. Yeah, at the moment we try to stick to certain code standards, do the usual code reviews, and yeah, well-known working practices. And we also aim for keeping our open source community open and in the front line of everything we do, and involving them, like sharing our roadmap with them, giving them ownership on the repository, so you can actually moderate, you can actually triage issues. Well, I will share a little bit more about that now. So the main focus of this presentation was to announce OSIS itself, the rewrite, and also the new community project that we aim to retake again. There are many ways to interact with us. Either you could fork, patch the code base, submit a pull request. The entry level is not so high. Golang is a very approachable language, and the application logic is not really is not as unapproachable as it sounds. But if you are not into coding, there are also ways to contribute, like documentation. Writing documentation is very important for us, so we try to generate a lot of documentation from the source code, which Golang does pretty well, but there are limitations to this approach, obviously. There's the human factor that it should be there, not just code generation documentation. There is internationalization, for which we use, I do not remember the name of the service. So in internationalization, basically, you need to translate any strings that we have in all our clients into language, into your language, or if you're native English speaker, into English, or if you have two languages, then yeah, you know what it is. There are bug reports also. The software is not full of bugs. There's plenty of bugs, and any help catching them is nice and appreciated. And then, of course, there is discussion, hanging out. We do have a public chat where you can join, and we are mostly a remote team. Well, ownCloud has always been a remote company, a remote-friendly company. Half of the company has been always working remote, especially now with Corona. 90% of the employees have been working remote. I'm one of the only ones that go to the office, actually, because there are no kids there, so it's nice. But yeah, we are always on the chat. We are always on a Teams call, so we work 24/7 on Zoom or on People Button, sharing always our screen. So you can literally join and see what we are working on at this very moment. These are ways to interact with us, and I will invite you to check ownCloud.com/infinite scale. Then just wanted to showcase a little bit how easy it is to run OSIS from source. So the only requirements you will need is the Go toolchain. So you would just need to clone the repository, cd into it, build it, and run it, and you should have the entire thing just up and running. Originally, I planned to do a small demo, but I think that won't fit in here. It's very, very small. So yeah, that is what we wanted to share with you guys. If you have any questions, please feel free to fire them to me.